Hello, I'm Dave Pattison of EtherTek Circuits. In this video we'll go over the RMS 100 onboard isolated voltmeters. Please note that this also applies to the RMS 200 and 300, although those boards have more voltmeters. Part 1 of this video will go over how to hook up the voltmeters, and Part 2 of this video will show how to use the voltmeter web interface. First though, some voltmeter facts. Each voltmeter has a pluggable connector for easy wire insertion. Each voltmeter has a range of minus 100 volts DC to plus 100 volts DC. Each voltmeter has its own 24-bit Delta Sigma ADC chip. Each voltmeter is isolated from each other and from the rest of the RMS board. 2500 kilovolt isolation is achieved by using a chip-scale air core transformer on each voltmeter circuit, and they all have a blue LED that will flash as the voltmeter takes a reading. So the question is why use an isolated voltmeter? There are many good reasons to have isolation and really only one drawback. Isolated circuitry is expensive, but as you will see, the extra expense is well worth it. For this demonstration, we have 4 6-volt batteries hooked together in series to make a larger 24-volt battery bank. Let's get started by powering the RMS board with 24 volts and letting it boot up. We'll wire this up so that the positive terminal on the battery bank goes to the positive input on the RMS voltmeter, and the negative terminal goes to the negative input on the RMS voltmeter. Next, we will hook up the same 24 volts in reverse polarity to voltmeter number 2. Notice that the web interface now shows a negative voltage represented by red. Now we'll hook up voltmeter number 3, and we'll do it in proper polarity like voltmeter number 1. So in a nutshell, without isolated circuitry, sharing the power between the DC input and the voltmeters would cause a dead short that would ruin the board. Thank you for watching the video, and part 2 will show you how to use the web interface with the voltmeters.